Is that right?
Yeah.
Yeah, I think so.
Go.
Just give me a minute. I'll let these younger ones go so that we can focus on that. Let's quickly check.
My dad's not here, but I'm going.
No, so let me check. Okay.
Yeah.
Ridley.
We're all going. We can go.
Okay. All the three kids with you, sir? Okay, all right. We had a good fun time with the younger ones, okay? Kids fresh from elementary school. Okay, so let's do a quick. Everybody, can you guys turn on your video if it's okay? Myra, Davik, Anika. Okay, if you guys are not comfortable, that's okay. But ideally, I would assume you guys to keep your videos on because that's when the interaction with the teacher gets a little better. Hey, Vishwa.
Hi, sir.
So, I'm not sure if you guys got a chance to look at what we're going to cover today. Let me read it for you guys. So, today we will be talking about equivalent expressions, factorizing polynomials and evaluating expressions. First of all, if I ask you guys what is expression? What is expression? No. There's a difference. That's why I'm stressing on that. What is expression? Davik, do you want to teach me what is expression? Okay. Let's see what Anika says. Davik, I'll wait for you to describe that to me. Yes, Anika, go ahead, brother.
Something that shows the relationship between numbers.
Okay. Davik, any thoughts? Abhi, Biswa, any thoughts? Okay.
Wait, I think something that doesn't have an equal sign.
Say that again.
It doesn't have an equal sign.
It doesn't have equal sign or it has equal to sign?
Doesn't.
Doesn't. Davik, do you agree?
Yeah.
How about Abhi? Abhi, here. Do you know what is an expression and what is an equation?
An expression is the problem, and the equation is the problem with the answer.
Okay, let me give you guys a lame example. If you all came to the class and I keep smiling throughout or I keep crying throughout, but not teach anything. What you're seeing is just my expression. What is the outcome? Nothing. You're just seeing your teacher smile. That's it. So there's no outcome. So same way, when you compare an equation and expression, that's the primary difference between them. An equation represents a situation where you have an outcome. Something equals something. You have an outcome. Now you look at this situation. If I'm talking about x plus y, this is an expression. You don't know what x plus y. Like my smile means nothing to you guys. This is expression. No outcome. If I say x plus y equal to 15, now you know what you're heading towards. This is your outcome. When you add x and y together, you get a 15. You're talking about an equation. So the primary difference between expression and equation is that your expression doesn't have an outcome, your equation has an outcome. Other way to look at it would be an expression doesn't have an equal to sign, your equation has an equal to sign. Hey Thanu, hi Sanjita. Is everybody with me so far? We just talked about the basic difference between equation and expression. So in today's class I'm not dealing with equations. Let's start with expression. Now if I have, can you guys see the board okay?
I can see it.
Yep. Okay. Hey Tansi.
Yeah.
Hi, sir.
Look at. What is the difference between these three that you see right now? They are all expressions, okay? None of them have equal to sign. So they are all expressions. What is the difference between this, this and this? Tanu, Tansi, Sanvita, anybody? Biswa, Anika, anybody? What is the, yep, go ahead Sanvita.
They all have a different amount of factors in the equation or in the expression.
Different amount of factors. How about you, Siddharth?
There's like more stuff being added to the expression.
More stuff added to the expression. Davik, what is your definition or interpretation from what you see on the board?
I was thinking that there's like different amount of factors in each one.
Sorry, Beta, one more time.
Different amount of factors in each one. Like,
Different amount of factors.
yeah.
Could you please repeat what you said, sir?
So what I'm saying is, you're seeing three expressions. This expression is x squared. Time to dispose of some of the markers. Okay. So this one that you see, this is x squared. This one that you see has x squared plus 2y. This has x cubed plus 2x squared plus 7y. Yes, Tansi. I was saying what is the basic difference that you see between these three? One thing is common, they are all expressions because none of them have equal to sign, so they are all expressions. Yep. Yes, Tansi, go ahead.
I thought it was because there's like different amount of variables in each one.
Okay. So we call them terms. Any two things that is separated by a plus or a minus is called a term. Here if you see, this is an expression with one term. This is an expression where you have two terms, x squared and 2y. These two are separated by this plus sign. If you look at this one, it has three terms. X cubed is separated with this one with a plus sign, 2x squared, and then there's another separator, another plus. Even if it is minus, that's okay. But you have three terms. So you count the number of terms based on how many plus or minus signs you have in between. So this is an expression with one term. This is an expression with two terms. This is an expression with three terms. This is called monomial. This is called binomial. And this is called polynomial or trinomial expression. Do you guys recall it?
Yes, sir.
Yep. Okay. So now if I say, if you look at this one, 2x squared versus x cubed. This is considered one term and this is considered one term. No matter what is the number here, you are not going by the coefficient, you are only going by the separator which is plus or minus. Okay. So you will deal with this kind of situation where you will say, okay, you have a polynomial, factorize it. So we'll come to factorization any which way. But right now, first thing first is we have to be very, very clear about what is the difference between monomial, binomial or polynomial. So there are two types of expressions basically at a broad level. One is called monomial when you have only one term. If I say 60x cubed, this is a monomial expression. There is no plus or minus. There is only one term. This is monomial expression. Anything which has more than one term is called polynomial expression. So be it a binomial, be it trinomial or quadrinomial or pentanomial or hexanomial, anything which has more than one term is called a polynomial expression. Is that a okay understanding to begin with? Everybody, Anika, Tanu, Davik, Myras, Abhi, everybody. Now comes the actual thing where we will deal with more and more interesting stuff. People will say, okay, how do you divide a polynomial by another polynomial? Now I'm talking about, let's say, x squared plus 6x plus 9 divided by x plus 3. So if you look at the numerator, you have a polynomial, 1, 2 and 3 terms. If you look at the denominator, here also you have two terms. because there is one separator here. If you divide this by this, how would you go about it? Any thoughts?
I divide like the like numbers like 9 and 3 and like 6x and regular x.
Okay. Any other thought? This, yep, Tansi.
Could you repeat the question, sir?
I have an expression, a polynomial, x squared plus 6x plus 9, and I am trying to divide that by x plus 3. How would you go about doing it? If I had to divide 9 by 6, that would have been easy. I would have said 3 into 3, and 6 is 3 into 2. I will do tic-tac-toe, 1 and 3 and 3 gone, 3 by 2 is my answer. But here, I am dealing with a situation where I have unknowns. If you look at this polynomial, x squared and x is a variable here. So there is no straightforward calculation that we can do. Yes, Sanvita, go ahead.
On the numerator, x squared plus 6x plus 9 they're like perfect squares. So it could also be x plus 3 in parentheses squared divided by x plus 3, and then you would just cancel out.
Sanvita will make me jobless one day soon. Yeah, this is what you were saying?
Yeah.
This is nothing but x plus 3 whole square. So x plus 3 whole square by x plus 3, that is, it is as good as x square divided by x. Or you can, don't mix it up. You will say x plus 3 whole square is nothing but x plus 3 times x plus 3 divided by x plus 3. You can do tic-tac-toe this way also. So the answer is x plus 3. So basically what Sangeeta was saying was that whenever you have a polynomial to be divided by another polynomial, you have to find out ways to factorize it. We converted this into a factor, something to something, and then we looked at the opportunity of breaking it down. Yeah. So this was just a sample example. Now we will look at what are the different options, what are the key building blocks that we need to be aware of, and how do we apply those for solving polynomials. We will start with the quadratic equations and then we will go to polynomials with higher degree. Anybody in the class who has a different expectation with respect to this one, or it's okay to believe your teacher? No response is not a good response. Are you all okay to begin with? Okay. So there are some building blocks that I talked about in the previous class, which is called algebraic identities, or the basic formulas that we have to know by heart. A plus b whole square equals a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square. A square minus b square is a plus b into a minus b. And again, this is simple. You are doing a plus b whole square, that is a plus b into a plus b. And when you do that, it's called distributive property. When you apply it, you get this. We have done that in the previous class. If anybody has any doubt, we can do that again. Not a problem. Okay. Similarly, a minus b whole square. Anything if you're talking about a plus b whole square is nothing but a plus b times a plus b. As simple as that. Like you say x square is nothing but x into x. Okay? Same thing. And when you use the distributive property, break it down, this is what you will get. So these formulas we end up memorizing, which will help us to do more calculations. But are you guys clear about these formulas, or any doubt? Vishwa, you were in the class, so I'm assuming that you are clear about it. No doubt. Abhi? Myra, are you clear about these formulas?
Yes, sir.
Ananya, okay? Now, so let's come back to the same question that we were trying to solve, which Sanvita actually helped me solve. The equation was that, okay, x squared plus 6x plus 9 divided by x plus 3. As soon as Sanvita saw this question, she was trying to relate it with one of these formulas. And she said, okay, I have all as plus. And can I write this 9 as 3 squared? So now I have a squared, b squared and something. So can this 6 be written as 2 into 3? So now look at this, a squared plus b squared, 2a and b. Oh, this is a plus b whole squared. So immediately it rang the bell for her, say, okay fine, whatever I had as an equation x squared plus 6x plus 9 by x plus 3, the numerator itself, she was able to map it with this formula and say, okay fine, this is x plus 3 whole squared divided by x plus 3. After that, whatever she did, that was the easier part of it. But the main objective was, how do I convert this into factor form? How do I factorize it? And then I can do my tic-tac-toe. And tic-tac-toe is a technique I use for, I call it tic-tac-toe, there is nothing that I have devised. But it is more like a technique for simplifying your calculation. Okay? If I have, let's say, 16 by 8, I'll say, okay, 16 I can write as 8 into 2, and 8 I can write as 8 into 1. I can do tic-tac-toe. I have 2. So same way, if I have x plus 3 whole square, I'll say x plus 3 into x plus 3, and here I have x plus 3, so I can knock off one of the x plus 3 above and below, and I have x plus 3 as an answer. Yeah. Is everybody with me so far, or I'm just going too fast and getting everybody confused purposefully? I'm getting everybody confused purposefully, and that is when Thansi raised her thumb, gave me a thumbs up. Okay. All right. Davik, okay? Anika, everybody okay so far? Now, so one thing we saw that when we have a quadratic equation or a polynomial to divide by another polynomial, we looked at factorizing it and we tried mapping it with these formulas. Okay? Now, will we always have a situation where we can map it to one of the standard formulas? Probably not. How about this? If I say x squared plus 6x plus 8 divided by x plus 4. Now let's see who has what clue for solving this one. How would we go about this? I will be tempted to map it to one of the formulas, okay? So a squared plus something plus 8. But is 8 a square? No, right? 2 2s are 4, 3 3s are 9. We don't get to 8. So this is not a perfect square. So I don't get a b square. So I'm stuck now. What do I do? Any clue? Davik, Vishwa, Sanvita, Thansi, bail me out. I'm stuck. Yes, Vishwa.
Would we simplify 16 by 8?
16 by 8.
Yeah, 16 over 8.
But how? Somebody has to bail me out. Your teacher is stuck. Shiv, tell me.
Sir, we have to factorize the answer.
How?
We have to factorize the quadratic equation. So it's very simple. We multiply x squared by 8. So that's 8 only, no? That's just 8 is 1. X squared can be put, the coefficient for x squared would be 1, right? So 1 and times 8 is 8. Now you find factors of 8. 2 and 4, right? Because 2 and 4 make 6 for the 6x. So then you can separate 6x into 2x plus 4x. And then x squared plus 2x plus 4x plus 8 can be turned into x multiplied by x plus 2 plus 4 multiplied by x plus 2, which can finally be simplified and factored into bracket x plus 4 bracket, and then another bracket x plus 2 bracket, and then you can put that above.
So you are doing perfectly fine, Safe. There is nothing wrong with what you said, but it will be more effective when it is done mathematically. Okay. So let me give you guys a method to the madness. Now, when you see, ultimately this is something that I have to factorize. I have to convert this into something. Okay. And we see that this is not a perfect square. So this approach doesn't work. I have to look at the second approach, the alternate approach. So let's say if I call this my first approach is not working. What is my second approach? Okay. Sangeeta, you're trying to say something?
Well, I didn't get the answer yet, but I thought you could factor the numerator by like finding two numbers that add up to 6 and are multiplied, and then have a product of 8.
That is what I'm going to do now. That is exactly what I'm going to do. So any equation, any quadratic equation, any equation which, or any expression which has maximum power is 2 is called quadratic expression. If it is equal to, it is called quadratic. It's called, if you have equal to, it's called quadratic equation. Now what Siv and Sangeeta were trying to do was, let me map this to the standard form of the quadratic expression. This is the standard form of a quadratic expression. Ax squared plus bx plus c. Okay. Ax squared plus bx plus c. This is a standard form. If you compare this with this one, right? Here you, in place of a, you have a 1. In place of, see, this is a b is the coefficient of x. So your b is nothing but 6. And c is your constant value, which is 8 here. Okay. Am I getting you guys confused, or so far it's okay? Viswa is confused. Sangeeta is okay. Davik is okay. Alright. So what does the thumbs down mean, Davik? Getting you confused or not getting you confused? It's okay? Okay. So whenever you see a quadratic equation, okay, 80% of the work that we will do will map to a quadratic equation actually. Yes, Abhi, you're saying something?
I was a little confused because it was a bit fast, so can you slow it down a little bit?
Yes. So what I'm saying is, we are trying to divide this with this. Okay. When I look at this, the numerator, ultimately I'm trying to convert this into something. Okay. I don't know what is this x here right now. Let's say a into b. I'm trying to break it down into a into b. Okay. That is, but for that, this 8, is it a perfect square? I'm just comparing it. 8 is not a perfect square. So I cannot take this option. I have to look for a second option. Second option lies in this formula. This is called my standard form of a quadratic expression or equation. Okay? Standard form. Meaning, if you talk about a quadratic expression, you have something with a power x squared with a coefficient a. Next power of x, that is x to the power 1 multiplied by a coefficient b, and then c, a constant term. Okay. So let's see, x to the power 2, x to the power 1, and then here you can say x to the power 0 also, which is 1. So this is c. So 2, 1, 0 power. This is a standard form, a, b, c, x to the power 2, x to the power 1, and then c. Okay. So this is a standard form. Now, what this second approach says is, that's what the Siv was trying to do was, that look at your expression, map it with this one, and find out what is your a. Your a here is 1, which is the coefficient of x squared. Coefficient of x squared is 1 here. What is your b? B is the coefficient of x, that is 6. What is your c? That is the constant term 8. First thing you have to do is multiply a and c. And what do you get? 1 into 8 is 8. Now look at what are the factors of it. So 8 you can factorize as 2 into 4 or 8 into 1. These are two possible factors of 8. Correct? Is everybody with me so far?
Yes.
So now look at these combinations and see which one helps you get to this. 2 and 4. By adding 2 and 4, you get a 6. 8 plus 1 or 8 minus 1 doesn't get you 6. So this is your option that you're looking at. So now what it means is x squared plus 6x, I can break it into 4x plus 2x. And then I have an 8 here. Now you look at this. Some magic has happened. Pick first two terms and last two terms. Here what is common? X is common. So it becomes x plus 4. Plus here 2 is common. So take 2 out, it becomes x plus 4. Divide by x plus 4. Now you have common multiplier for both the terms. So you can take it out as a x plus 4 is common, and here you have x plus 2. This is just the reverse of distributive property, okay? And you have x plus 4. Now x plus 4 and this x plus 4 you can do tic-tac-toe, your answer is x plus 2. I'm not worried about the answer, or I'm not concerned about the answer. What I'm trying to say here is, when you have a situation where you cannot map it to a perfect square, this is your alternate option to simplify it or to factorize it. What you will do is, you will map it with the standard form of the quadratic expression, look at what is the value of a, b and c, multiply a and c and see what is the value, and then see whatever is the multiple of a and c, see what are the possible factors you have. How do you get 8? 2 into 4, 8 into 1. That's it. There is no third option. Between these combinations, you'll say, okay, which one I can add or subtract to get the b part of it. So 2 and 4 together gives you this value. I mean, by adding 2 and 4, you get this. So basically, all this that we are doing here, it gives you a way to break this term into two pieces. You can always say 6x equal to 5x plus 1, but that will not solve any purpose. That will not help you factorize it. So whatever we are doing here, this just gives you a way to factorize it successfully. Abhi, did I get you more confused, or I was making a little bit sense?
I'm okay now.
Okay now? Tansi, Ananya, Anika, everybody okay?
Yeah, good sir.
Yep. Tanu?
Yeah.
Yeah, not sounding very convincing though. Davik, was it making sense a little bit?
Yeah.
So there are two methods, okay? So basically, see, don't overwhelm by every word of mine. Everything that I said, there is a lot of blabber into it. Only pick the thing that is relevant for you. So what the summary of what I have told in last 10 minutes is this, that if you have to divide a polynomial by another polynomial, you have to explore what are the options you have, right? There is no silver bullet for solving every problem, correct? So first is, okay, I have some standard formulas. Does my input map to any of these? If that is the case, then I get a factor straight away. But here in this case, we found that, okay, this is not working. Then we looked at the alternate to break it down. So this is the second method where we compare that with the standard form of the quadratic expression, and then we were able to successfully split this. I hope I have made a little bit of sense to everybody. Okay, now let me do a quick check of my own skills or teaching skills, whatever I explained you guys. Let's see if you are able to apply it now itself or not. If I say Okay. Yeah. Somebody raise hand. Can you guys factorize this for me? 2x squared plus 13x plus 18.
Who's the next one?
Okay. Can you guys help me factorize this one? I just want you guys to factorize this. 2x squared plus 13x plus 18. I want you guys to convert this into something. Is the mosquito still bothering you? Or you're
No,
okay?
it's fine.
Yeah, okay. Can I expect you guys are giving it a try? Shiv, Vishwa, Davik, Tanu, Ananya, Anika, Tansi, everybody, Sanvita? Okay. I'll stay quiet for 2 minutes. I will only give company to Siddharth here. Okay. Try it. It's okay. We'll try, we'll learn, we'll make mistakes, and that's fine. Yes, Abhi.
So, when you say factors, like, would you say, like, combining the, like, terms and things like that?
One more time.
Combining, like, terms?
By factorizing, I mean whatever I have, I want to convert this into something. Like when you say factorize 8, what do you say? Okay, it's 2 times 4. Those are the factors of 8, correct? I want to find out the factors of this polynomial or trinomial, whatever you call it, or quadratic expression, whatever you call it. Yes, sir. Tell me, what's happening?
X plus 2 to x plus 9.
Yeah, you got it. Yeah? See what did you do? So you had 2x plus, so what did you do? You multiplied a and c, right? 36. And you said, okay, fine, 36, what are the factors of 36? 1 into 36, 2 into 18, 3 into 12, 4 into 9, 6 into 6. That's it. Now, among all these, you said, okay, fine. Which one is making 13 for me? 4 and 9. See? Yeah, you got it. So basically, all this that we are doing here truly helps us split this into 2 parts so that we are able to factorize it, right? Otherwise, 13x I can say 10x plus 3x, but will that help? No, right? So this gives you the method to the practice. Yeah. Okay. Yes, Sanvita.
I got in parentheses 2x plus 9 times in parentheses x plus 2.
Okay. How about Shiv, Davik, Vishwa, Abhi, Tansi, Tanu, Moira, Anika?
I'm still working on it, sir. I'm getting close to the answer now.
Okay. And one recommendation to everybody, okay? One is, don't trust anybody. Find your own answers. Yes, Abhi?
Sir, can you re-explain factorization?
I will. So that's why we are practicing, right? I mean, I just said once, and I'm a horrible teacher when it comes to explaining something, right? If I explain just once, not everybody would understand it. So that's why we are doing practice, so that it will give us that opportunity to re-look at it one more time.
Okay.
Anybody else who is waiting for, who is about to complete it, or everybody else is waiting for me to come back to it?
I'm still working on it, sir.
Okay. What's happening, Myra? Yes, sir.
I got the same answer here. 2x plus 9 multiplied by x plus 2.
Okay. How about Myra? Myra, are you trying?
Yes, sir.
Anywhere close to being done? Ananya? Anika? Where are we?
I'm a bit confused.
Little confused? Okay. Not a problem. Anyways, that's the reason, right? I just explained once.
Yeah, I'm confused too, sir.
Okay. Okay, so here's the thing. Some of you were able to kind of digest this. Davik, how about you, beta? How far are you?
I'm still a little confused.
You're still confused? Okay. So that's where I have a role to play. Let me come back to this. So again, I am so what do you call it? I'm so much process oriented, okay? Meaning I have a problem to solve. First thing I'll do is I'll look at this. Do I have a ready-made solution? Do I have a straight away way to map it to any of this thing? So, okay, I get 2 and 13. 2x squared, this is not a perfect square. 18 is not also a perfect square. So it doesn't look like I can map it to any of these. Then, second approach, meaning I have to map it with my standard form of the quadratic expression. What is my standard form of the quadratic expression? Ax squared plus bx plus c. This is my standard form. Now, what is my a with respect to this expression? A is equal to 2. Okay. What is my b? B is equal to 13. What is my c? C is equal to 18. So far, nothing magical. Okay. This is standard form of the quadratic expression that we have noted down, and we just found out these coefficients. Okay. Now the next thing we have to do is look at a and c, multiply them. A into c is how much? 2 into 18 is 2 into 18 is nothing but 36. So the next step is, this is what we did, right? A into c, and then whatever value you get, factorize them and see which one is of interest for you, if there is one. So 36, if I have to factorize 36, I can write this as 1 into 36, 2 into 18, 3 into 12, 4 into 9, 6 into 6. These are the possible factors of 36. Yeah? Now, which one is of interest? I have to get a total of 13. 1 and 36 will never give me 13, be it a plus or minus. 2 and 18 also will give me either 20 or 16. When I add them, I get 20. When I subtract, I get 16. So this is also not working for me. 12 plus 3 gives me a 15. Or 12 minus 3 gives me a 9. So that is also not working. How about this guy? 4 plus 9. 4 plus 9 is 13. Bingo. We got what we wanted. So that means I can use 4 plus 9 as a factor of these two the output of these two multiplication. This I can use for splitting this. That means I can split 13x into 4x plus 9x. Okay, good. Now we at least have a way to move forward. 4x plus 9x. Okay, 13x is becoming or splitting into 4x plus 9x. 2x squared plus 4x plus 9x plus 18. Now, here let's take first two terms, last two terms together and see what is common here. Here you have 2x common. 2x into x gives you 2x squared. 2x into 2 gives you 4x. Okay, so let's take 2x common here. What I have is x plus 2 between these two terms. Now here, what is common? 9 is common. If I take 9 out, it becomes x plus 2. So I have 2x times x plus 2 plus 9 into x plus 2. So this is a common factor for both of them. So I can write this as x plus 2 times 2x plus 9. Yeah? Now there is something magical about it. But so far, are you guys clear about it? Abhi, Anika, Davik, everybody clear so far? Now there is something magical about this. I said 13x I can split as 2x plus, 4x plus 9x, okay? So I have written 4x plus first and then 9x, okay? How about, and then we are taking first two terms. What if I write 9x first and 4x later? What happens then? Will it give me anything to worry about? It will not. Look at this. I wrote 9x first and then, okay, so here I have 2x squared plus 9x. I take these two terms together, these two terms together. Here what is common? Here I have only x common. It becomes 2x plus 9. Okay? And between these two terms, what is that is common? Only 2 is common. So it becomes 2x plus 9. See, what did I get? X plus 2 times 2x plus 9. Same thing. Even flipping them, whichever you want to take first, that doesn't hurt. It gives you the same answer. So, what I'm trying to say is, when you use this method to split this, you don't really have to worry about which one to keep first. 4x plus 9x is same as 9x plus 4x also, right? So, which one you are writing first is not going to hurt you or is not going to change your answer either. Did I make enough sense or no? Davik, Ananya, Myra, Abhi, anybody?
Yeah.
Making sense? Tanu, Tansi, is it digestible so far, or you guys need something to digest? Now, so all of you who have been to one of the grocery stores, there is something Indian grocery stores rather. So there is something called hajmola. That is when you eat something which you are not going to digest, you can swallow. I mean, not swallow. Just kind of slowly eat that. It will help you digest the food. So you can keep a bottle of hajmola. Whenever I teach you guys something that is not easy to digest, you can use hajmola for digesting it. Okay, that was a bad joke or a bad joke. But is this part clear so far? Myra, clear?
Yes, sir.
Okay. So essentially, when it comes to factorizing a polynomial or a quadratic expression, there are two methods. One is you map it with one of the standard formulas or use the second technique. Now, there is more to it. There is something called equivalent expression. What do we mean by equivalent expression? Anybody?
Expressions equal on both sides.
Both sides. In expression you don't have second side actually. You don't have equal to. So I'm talking about equivalent expression. Yes, Sangita.
Like two expressions that have the same value.
Okay. Now, before I say okay or start doing my gymnastics here, anybody has a different point of view? Shiv, Daivik, Ananya, Nika, Thanu, anybody? Tansi? What do you mean by equivalent expression? Yes, Vishwa, go ahead.
Maybe even if we change the variable, it's still equal.
Yes and no. Okay. I will wait for another way of describing it. Shiv, any thoughts around that, beta?
So it's two equations that are equal.
I'm not saying equation, I'm saying expression.
Expressions that are equal would be congruent expressions like a plus b would be equal to a plus b. Then even if we change both sides, it would still be the same.
Okay. So let me give you guys some background to it. Do you guys know what is this called? These are called equivalent fractions, meaning their value is the same. Meaning if you have a fraction and if you multiply and divide by the same number, you get this. If you have, let's say, same fraction, you decided to multiply and divide by 10 and you got this as 10 divided by 20. This fraction and this fraction are called equivalent because they have the same meaning, same value. In terms of expression, it extends the same concept where you say, if I have an expression and I'm creating multiple copies of it, it's the same. So basically, it's like you guys see my smiling face doing nothing, just smiling in front of you all. Whether it's one face smiling here or I create a photocopy of my face and paste 10 photos here in front of you and every photo is smiling, doing nothing. Outcome is the same. It doesn't make any difference. So is the case. Here, if you have an expression, let's say x squared plus 4x is one expression. If you multiply that by 3 or multiply that by 203, your overall behavior doesn't change. It just helps you look at it with a different view or different mirror or different glass. That's it. Overall behavior doesn't change. Meaning, if you have an expression, if you multiply or divide that expression by a common number, each and every term of the expression is multiplied or divided by a common factor, it is called an equivalent expression of the parent. So, between this and this, let's say this was my expression and I multiplied this whole expression by 3 and it became 3x squared plus 3 times 4 is 12x. This expression and this expression are equivalent to each other because this is generated by multiplying this expression by a factor 3. Yeah? In a way, it helps you to simplify things in future. You'll say, fine, if I have, let's say, expression 2x squared plus 18x plus 16 and divide that by, let's say, x plus 9, you will say, okay, fine, I have a 2 is common here, here and here. I will just make the numerator, find out the equivalent of the numerator expression. It becomes x squared plus 9x plus 8 divided by x plus 9. Now, this expression and this expression are called equivalent. So basically, you factorize, you divided this whole thing by 2 and made it a simpler looking expression and kept this as a factor outside. So, be it equation, be it expression, you will deal with this equivalent equation or expression thing very often. Meaning, whenever you have an expression or equation to deal with, you have the freedom and luxury of dividing each and every term or multiplying each and every term of the equation or expression by a common number, and that doesn't damage the or change the behavior of the equation or expression that you're dealing with. That is what is called equivalent expression. So simply multiplying or dividing each and every term of an expression by a common number is what is called equivalent expression. I mean, this expression was developed by multiplying the whole thing by 3. So this is your equivalent expression for this one, or vice versa. Does it make sense? Or when you guys go quiet, right, I get a little worried. Everybody with me?
Yes, sir.
Okay.
Yes, sir.
Okay. So,
Yes, sir.
okay, wonderful. So we looked at what is equivalent expression, what do you mean by factorizing polynomials, and we touched upon, we just touched the tip of the iceberg, right? We just looked at some examples to deal with. And obviously, it'll become much more easier for you guys when we practice a little bit more. So I will certainly happily send you guys some assignment. Assignment as in, my assignments are not scary enough. These are like opportunity for you guys to kind of relook at what we learned. How do we apply that while solving it ourselves? Okay. So my assignment will be like now something that you can do in half an hour or 45 minutes for a week. Okay. So it'll not scare you guys for sure. But what is important is when you get the assignment, look at it with some amount of excitement that okay, let's see if this old man who taught us something, that concept, am I able to apply it here and solve it? If I'm not able to solve it, that means it's not my mistake, it's my teacher's mistake who did not teach it right. I will ask him again. Okay, so that's the purpose. My assignment is never meant for getting anybody in my class stressed out. If I ever do that, please feel free to let me know, saying, sir, you are giving enough assignment to get us scared or get us worried. Okay? Alright? Now, the next thing is evaluating expression. If somebody says, you have an expression x squared plus 6y plus 19x. Evaluate this for x equal to 5 and y equal to 9. Do you guys know what exactly has been asked here?
Simplify the expression.
No, so I'm just repeating myself. Okay, so let's hear Tansi and then I'll repeat again. Yes, Tansi, go ahead.
What they mean by evaluate is basically like substitute the numbers that you have into the variables.
Right. Sanvita, is that your answer too?
Yeah.
So basically, whenever you come across expression, function, or equation, when you hear the term evaluate, that means, see, if you look at this expression, it has just a relationship given here, that okay, x square of x value times plus 6 times the y value plus 19 times the x value again. But x, y, we know these are variables. X could be 1, x could be infinity, x could be minus 7. We don't know. So whenever you see the term evaluate, it simply means that this is a relationship given here. What will be the value of this expression if you have these value for these variables given to you? Okay. If somebody says, okay, evaluate x squared plus 4x for x equal to 9. It is simply asking us to substitute x here, 9 in place of x and see what happens. That's it. So anything that is being asked to evaluate, it is as simple as substituting the values that is given to you in the expression or equation and find out what is the total outcome. Yeah. So that's why I had purposefully kept this topic towards the end. Evaluating expression. I find it difficult to explain at times. When somebody says, okay, how do you evaluate expression? There's nothing, you have to just plug in the value, that's it. Right? If I say, find out the value of x squared, you'll be baffled. You'll say, what do you mean by x squared? What is x? I don't know what is the value of x. I'll say, okay, find out the value of x squared when x equal to 3. You'll say, now you are making sense. I'll plug 3 in place of x and get you the value of 3 squared, which is x squared now. Yeah. So evaluating any function or expression or equation simply means plug in the value of the variable that is given to you and see what the outcome is. Yeah. So evaluating anything should be the easiest of the problem to deal with. If you are in the exam and you have 10 questions to solve and one of the questions says evaluate, pick that one as the first thing because that doesn't need any thoughtful evaluation. You just have to plug in the value, that's it. That should be the easy picking because you guys anyways have the luxury of using calculator in the exam. So you just plug in the value and get it. Yeah?
Yeah. But we can't use calculator.
No, so when I say exam, my focus is always on SAT. So basically I'm getting you guys ready for SAT, okay? So when you go to 10th grade, 11th grade, when you're preparing for your college admission, that is when it gets interesting. You have stipulated time in your hand and then you have to solve X number of problems. And how do you make the best use of the time? How do you solve things without making mistakes? How do you get the maximum score that you can in that given time is where the whole strategy lies. So that's what I'm saying. If or any exam, right? I mean, most of the exams are very much limited by the time that is given to you, right? I mean, you will not have, okay, you have the entire day to solve 20 problems. Never like that. I mean, I never had that freedom. So you always have a limited time given. So if you, while you are solving the problems, if you end up spending a little more time on a given problem, that means you are cutting short on the time that you have for other problems. So your chance of making mistake increases. So that's why these are some of the techniques. I mean, I'm saying that if you have a problem where you have to solve for evaluating an expression, that should be your first pick. Or anything which is much simpler than that. Okay. Does it make sense to everybody?
Yes.
Do you guys enjoy my blabber?
Yeah.
Okay, good. Now, so blabbering is only to keep you guys awake. Sometimes I go a little off track just to make sure that it doesn't get monotonous for you guys. I can keep talking math for 2 hours, but then you guys will get tired of me. And the day any student gets tired of the teacher, that's end of story. At least for the teacher and the student relationship. Yeah. So that's why I'm just keeping you guys awake. Sometimes I do a good job with my jokes. Sometimes I make it a horrible attempt, but bear with me. Alright. So hope you guys learned something today. At least you got some opportunity to practice. And I will send you guys some assignment, meaning 8, 10, 15 problems relating to the topic that we have covered. Trust me, I'm not trying to evaluate anybody. I'm just wanting you guys to evaluate me by applying these concepts to see how easy or difficult it is to solve those problems. Okay? And if you guys get stuck, don't hesitate. Ask that question to me or put that in the group. Say, okay, out of the 10 questions, I got stuck in this one. Does anybody know how to approach this? If you get an answer, wonderful. If you don't, I'm here coming back to you a week after. So you can always send me a WhatsApp message also saying, okay, this problem I could not solve. Do you have an approach that you want to recommend? Or can you tell me or help me how to solve it? So we can do all that. Okay. So with that being said, I will let you guys go. It's almost time. And see you guys again next week. And some of you are meeting me in between as well. Yep. Alright. So have fun. Bye bye.
Bye, sir.
Bye bye. Bye bye. Bye bye.